Hello, friends. Welcome to another session on Quant. I am Orko. So, if you are visiting this site for the first, this channel for the first time, so what we do here, we talk about quant topics that are relevant for your CAT, SNAP, INMET, IFT kind of an exam. So, all uh, entrance exams based out of India. And as part of that we start a topic start from first sessions are very basic sessions talking about fundamentals, absolutely crystal clear your concepts, talk about all the formulas, shortcuts, tricks around or certain exceptions in certain cases. So we talk everything around fundamentals of that topic. Then we do a problem session one where we do foundational level problem or conceptual clarity level problems, which help you understand how to apply the concepts that you have learned in the previous session in a problem scenario. And then we come to the problem session two, which is typically the last session of that topic, where we talk about little advanced or little complex problems. So when I talk about exams like CAT, SNAP, IFT, it has all the possibility from problem level one or problem level two session. It does not mean problem level one sessions are absolutely cakewalk and cannot come in CAT. It has equal probability. So we took different type of problems, and if you understand that type, you should be able to solve that. So the idea here is, so we typically do around 6 to 8 problems in a session. But the idea is you go back and do a lot of practice. And then if you have doubt with any problem or anything you are practicing or anything I have explained, if you have any doubt, please feel free to drop a mail. So if you have any doubt on things that I have explained here, you can add a comment or drop a mail in my mail ID given in the description box. Or if you are practicing something and you have doubt, you want a session, doubt clearing kind of a session, you can reach out to me through a mail ID. We can discuss on that. So that's about it. So this is what we are trying to do. And today we talk about source and indices. This is the second problem session. So if you have not gone through the first foundational session first and then the problem level one, I recommend you highly to go through that first and then come to this session. It's not a follow-up on problem level one exactly, but you should go through the basics of search session. So I'll put them in the description box. You can check them out. But at least the fundamental session is very much needed for you to understand how we are solving the problem in this case. So with that, let's get started. But like I said, always when I show you a problem, don't just start continuing seeing the video through my solution. Try it at your end, take 2 to 3 minutes, try to solve the problem. Start your brain to think on how you should approach the problem. If you are able to solve, fine, come back and see my solution and see whether there is a different approach or the your solution is right or wrong. You can check that. Otherwise, even if you are not able to solve, your mind will start processing how to absorb this kind of problems and try to think, and then come back and see how am I thinking about solving that problem. So then you can understand it more real and you can correct it in the next problem, or you can make it a much more refined approach for the next problem. Okay, so let's see how we can start with this first problem. So if you see, it says a to the power 5, sorry, not, not a to the power 5, a into a to the power 1 by 5 whole to the power a to the power 1 by 4, which is equal to a to the power 4 into a to the power 1 by 4. And don't think 4 and 1 by 4 can get cancelled, because this is a multiplication. So that's the powers are should get added, not get multiplied. A typical one, a to the power m into a to the power n is a to the power m plus n, not mn. Okay, coming back to this, it has a to the power 1 into a to the power 1 by 4. So from here, if we can write, this is a to the power 6 by 5. So that means 1 plus 1 by 5. It has basically 1 to the power a to the power 1 by 4. This should be equal to a to the power 17 by 4. 4 plus 1 by 4 is 17 by 4 whole to the power a to the power 1 into 1 by 4. So basically 5 by 4. So this is given. So this one I can write a to the power 6 by 5 into a to the power 1 by 4, a to the power 17 by 4 into a to the power 5 by 4. This is given. So how we are doing this? A to the power m whole to the power m is at mn. The same formula. So both the bases are same here. So if both the bases are same, we can write 6 by 5 into a to the power 1 by 4 is equal to 17 by 4 into a to the power 5 by 4. This is given. We can just cross multiply. So 4 into 6 is 24. 17 by 5 is 85. Is a to the power 5 by 4 divided by a to the power 1 by 4. So from here we can write a to the power 5 by 4 minus 1 by 4, which is equivalent to a, is equal to 24 by 85. So this is equal to 24 by 85. And then from here you can write a is 24 by 85. 5 by 4 minus 1 by 4 is 1. Okay, so hope this is clear. So what you need to do is you need to be very cautious about each of the steps. Don't make mistakes in trying to do 4 here, a to the power 4 and a to the power 1 by 4. You should not cancel out each other because this is a sum, so you understand. So this is one problem that checks your foundational understanding of the properties of indices. Similarly, here a is the base, common base, and then both has a power. So the power should be equal because both the bases are same. So that's what we have used from this step onwards. Okay, so I hope this is clear. Any doubt, please drop a note or mail me. And so I think comment is better. If you can drop a comment, I will try to help you in that, and that will be beneficial for everyone. Okay, let's move to the next problem. This is a relatively simpler one. So if I do this, so first one is 1 plus 1 by a square plus 1 by a cube plus 1 by 1 plus 1 by a, sorry, a square plus the third one, 1 plus a plus a cube. Let's see. The first one becomes a cube in the base. So that means first one is a cube plus a plus 1 plus 1 by, if I see here, this a in the base, so a plus 1 plus a cube, 1 by 1 plus a plus a cube. So if you have understood the problem right now, it's very simple. So it's a cube. So basically what I'm trying to do, I'm trying to make all the denominators same. A, similarly 1 plus a cube plus 1 plus a plus a cube. So from here it is 1. So basically if I add all of them, your numerator and denominators are all same. Numerators individually will add up to the same as the denominator. So your answer is 1. Okay. But yeah, when this kind of problem arises, try to solve it step by step and try to equate the denominator or same for all of them. And that's when you can simplify. Okay, let's move to the next one. 7 to the power x equal to 2 to the power y equal to 14 to the power z. So if I consider all of them equal to k, so they said express z in terms of x and y. So if I consider two things at a time, so 7 to the power x equal to 2 to the power y, I will not be able to get the relation between z. And similarly 2 to the power y, 14 to the power z, I'll get a relation between y and z. And then again, similarly, I have to do certain things. So there are two ways to solve the problem. I'm trying to show you with k, and I will try to show you without k. But with, when there are more than two equal to sign, it's always advisable. If you recall your ratio class, it's always advisable to have a third variable and make all the ratio equal to one variable so that you can convert that. So 7 become k to the power 1 by x, right? K to the power 1 by x. Just a moment. k to the power 1 by x. 2 to the power y is k, so 2 become k to the power 1 by y. Similarly, 14 becomes k to the power 1 by z. So if you can see, I can write 14 equal to 7 into 2, basic. So 14 is what? K to the power 1 by z is equal to k to the power 1 by x into k to the power 1 by y. So from here I can write 1 by z equal to 1 by x plus 1 by y. So from here, since both the bases are same, I can write 1 by z into 1 by x plus 1 by y. So this is one way. So this is xy x plus y. So from here I can write z is equal to xy by x plus y. So this is. So see what is the relation you can establish from the given equation, and from there you can find out. So it's not only suffice to write all of them equal to k, it also needs to understand this. We can write this equation like this, so that there is a relation between all the three entities given to you. So for the third entity is equal to the first and second multiple. So uh, that's where you will get the answer. Okay. Let's move on to the next one. See what is given. A is 7 plus root 48, right? 7 plus root 48. AB is 1. So AB is 1. A is 7 plus root 48. So can I say B is 1 by 7 plus root 48? Right? 7 plus root 48. So we can rationalize this. And to rationalize this, you have to multiply with the conjugate pair in the numerator and denominator. So 7 minus root 48 is the conjugate of 7 plus root 48. So if something is A plus root B, the conjugate of that is A minus root B. This is something we have covered in the foundational session. So this is, so 7 plus root 48, 7 minus root 48. So this is nothing but A, denominator is nothing but A plus B into A minus B format. So we can write this as 7 minus root 48 and 7 square minus root 48 whole square. So that may become 7 minus root 48 divided by 1. So B is 7 minus root 48, A is 7 plus root 48, right? And they say what you need to figure out. So you need to figure out A square minus AB plus B square. Right? You can do a square of each of them, A, B, and multiply A and B, and then you get the answer. That's one way. But let's try to see if we can simplify further. So we can write this a square minus 2AB plus B square, so that I'm making it as a whole square. But since there are only one AB, I have written minus 2AB, so I have to add back one AB. So from here we can write A minus B whole square plus AB. So AB value is 1, I know, and A minus B whole square is 7 plus root 48 minus 7 plus root 48 whole square plus AB. Right, 7 plus root 48 is A minus B, which is 7 minus root 48. If I take out of the minus sign, minus 7 plus root 48. So 7 get cancelled. So 2 root 48 whole square plus 1. So that means 4 into 48 plus 1, or we can say 197 is your answer. Right? So you could have done with A whole square, B whole square, and then AB is 1, but it would have taken a little more time. That's why we just simplified the problem. Right? So I hope the step-by-steps are clear. Again, any doubt, please add a comment. We'll be able to help you. This is a very good problem, and I'll tell you why it's a good problem. So it shows 7 to the power 5x minus 7 is equal to 7 to the power 2 to the power minus 1 to the power 5 to the power 4 to the power 7. This is given. And forget about the left side right now. On the right side, I said when it's in this format, you always should start from the top. But if you see in the similar problem we did in the previous session, there is a 1, but it's a -1. So I know -1 to the power square is 1, -1 to the power cube is -1. So basically, can I say -1 to the power even is 1, -1 to the power any odd number is always 1. So this is given to me. This I already know. So here it is minus, here I have -1 to the power 5 to, sorry. Here what I have -1 to the power 5 to the power 4 to the power 7, right? So what will be 5 to the power 4 to the power 7? Is it a odd number or an even number? I know all the power of 5 is always an odd number because 5 is 5 to the power 1 is 5, 5 square is 25, 5 cube is 125. So it always ends with 5. Any power of 5 will always end with 5, right? So 5 to the power 4 to the power 7 will always be an odd number. So then this will become your -1 to the power odd number, because 5 to the power 4 to the power 7 is always an odd number. So that means -1 will always be, this will always be an odd number. The outcome will always be odd. So outcome will always be odd. That means outcome will always be -1. So outcome will always be -1. Just ignore this. I think I missed the minus sign. That's why I added. So -1 to the power any odd number is always -1. So can I say this is equivalent to 7 to the power 2 to the power -1? Because 5 to the power 4 to the power 7, this entire piece is an odd number. If this entire piece is an odd number, -1 whole to the power any odd number is -1. So this is equivalent to 7 to the power 5x minus 7. So there is nothing after this. This is a very easy one. So 5x minus 7 is equal to 2 to the power -1, or equal to half, you can say. So if you just cross multiply, it is 10x minus 14 is equal to 1. And then 10x is equal to 15, or I can say x is equal to 3/2. So 3/2 is the answer, right? So this is one way. This is the most common way of solving this. So anytime you see 1 in the power, you always try to see 1, though you do square cube of +1, it will always be 1. But for -1, when it's square, it's 1. When it's even number in the power, it's 1. When it's odd number in the power, it is -1. So -1 to the power even number is 1. -1 to the power odd number is -1. So that's what we need to understand from here. And once you understand that, then the problem is very simple. 5 to the power 4 to the power 7 is always an odd number, because 5 the power will never be a even number, any power of 5. So 5 to the power 4 to the power 7 or 5 to the power 1 lakh to the power 1 crore is also an odd number. So -1 to the power odd number is -1, and that's how we simplified the problem. Okay, so this is the last problem, and this is again a very good one. So we see there is no way we can calculate these individual numbers. Okay, there is no way we can calculate. So what we have to do is we have to find out certain things on which we can write them, or a certain common base on which we can compare them, right? For that, if you see the last one is possibly the simplest one, or not. I would say simplest is not the right word. Last one is basically given. So if I start writing from the first, last, it is 2, 2, 2, 2. So I know this is 2 to the power 2222, right? So this is 2 to the power something is given. Let's see if I can write all the others in the power of 2. Let's see, or I will not be able to write because 22 is not a power of 2, but I will identify the range. So what I mean by that is 22 whole to the power 222. So this is 1, the second one, 22 to the power 222. So if I can write, so can I write So 22, if I say 2 to the power 4 is 16. So can I write 2 to the power 4 less than 22 less than 2 to the power 5? 2 to the power 5 is 32. So 2 to the power 4 whole to the power 222 is less than 22 whole 222 is less than 2 to the power 5 whole 222, right? So can I say from here 2 to the power 888 is less than 22 whole 222 is less than 2 to the power 11110. So this is the range. So what can I see? 22 to the power 222, which is the second last number, is more than 2 to the power 888, but less than 2 to the power 1110. So that means 22 to the power 222 will always be less than 2 to the power 4 twos. So this number will always be less than this number, because this number is 2 to the power 4 twos, and 22 to the power 222 is less than 2 to the power 1110. Like this, we have to do the other two. So let's see the third one. Third one says 222 whole to the power 22. So for triple two, what is 2 to the power 7? 128. 2 to the power 8, 256. Again, recall, that's why I mentioned in the speed math session. These are the foundational list of things you should memorize or absolutely on tip of your toe, tip of your tongue, always. That's when you will be able to generate this kind of information very quickly. So 2 to the power 8 is 256. So it is always between 2 to the power 7 to 2 to the power 8. So the same way I can write 2 to the power 7 whole to the power 222 is less than triple 2 to the power 22 less than 2 to the power 8 whole 22. So this is 22, sorry. So then I can write this 7 into 22 is 154. So 2 to the power 154 less than triple 2 to the power 22 less than 2 to the power 176. 8 into 22 is 176. So 2 to the power 176. So this third number I see is less than the second number. Second number, the lowest value, it is more than 2 to the power 888. And the third number is less than 2 to the power 176. So the third number has to be less than the second number, and second number I know always is less than the first number. Now get to see what was the first value given to you. First value given to you is, okay, yeah, the first value given to you is 2, 2, 2, 2, 2. Okay. Now there is no power, and how you make it as a power of 2? So, okay, for this, if we can near time, let's see, I will tell you. So I know 2 to the power 10 is 1024, 2 to the power 9 is 512, 2 to the power 10 is 1024. What is 2 to the power 11? Let me do this, 2048, right? 2 to the power 11. Similarly, 2 to the power 12 is how much? 4096. Okay. 2 to the power 13. I don't have to find out the exact one, but it should be somewhere around 8K. 2 to the power 14 will be somewhere around 16K. 2 to the power 15 will be somewhere around 32K. So can I say 32K means 32,000 and 16K means 16,000? And this is 22,222. So that means, can I say 2 to the power 14 is less than triple 222 less than 2 to the power 15? So this lies between 2 to the power 4 and 5. So can I say, in my scenario, problem one, number 1 more than number 2, more than number 3, more than number 4. So it is just, if you have to arrange in a descending order, it's just the reverse order that is given in the problem. So 2 to the power 2222, that's the highest. The second one is less than 2 to the power triple one zero and more than triple eight. Third one is more than 154, less than 176, and the fourth one is between 14 to 15. So obviously I know my fourth one is the lowest and the first one is the highest based on the power of 2 that represents this number. This is a very unique problem, and so see how we have done it. We have got one number and its power, and we just try to simplify with a range to see whether we can tell certain things about all the other numbers with a power of 2. We are not trying to find out the exact value, but we're trying to find out a range, and from that range we are deriving which one is higher, which one is lower. Okay, so hope this is clear, and this session is helpful. So if you have any doubt, like I said, drop a comment, and if you need more help, you can drop a mail in my mail ID in the description box. Yeah, if you have see the video till now, please like, share, subscribe for the motivation. It takes a lot of time and effort to get this problem and think through on which problem we want to pick. I'm not typically be making a 2 hour long kind of a session, so where we cover the entire topic, but we'll possibly go there later. But as for the understanding, I want to keep it light, small size, which you can chew at a time, so which you can understand at a time. So a good half an hour, 40 minutes kind of a session we are trying to build. So it takes time how to modulate and how to give what information or what problem we wanted to solve given the scenario. So if you like the effort, please motivate us by doing like, share, subscribe, and if you feel there are certain things that needs to be changed, there are certain things that can be improved in the way we are conducting these sessions, please share your thoughts in the comment, and we'd love to incorporate them in the coming videos. Okay, so that's about it for today. Thank you. See you next time. Bye.